Okay, so we have been given a right angle triangle, and we have to label the three sides as hypotenuse, opposite to theta, and adjacent to theta. So you can read the question properly and make sure you get the sense of what you are to do. So we have to label this right angle triangle. So here we have the 90-degree angle right here. That's our 90 degrees. All right, and so the side that faces that 90 degrees is the longest side of the triangle, called the hypotenuse. All right, so now the acute angle, that angle that is less than 90 degrees. The other two angles must be less than 90 degrees, by the way, because the three angles in a triangle add up to 180. And if one angle is already 90, then the other two must have a sum of what? 90, because 90 plus 90 is 180. That makes this angle here, an acute angle, meaning less than 90 degrees. So our angle theta is an acute angle, and the side that is opposite it is called the opposite side. It's opposite of theta, the acute angle that we're talking about. And the side that is next to, right, that is right there next to theta, that is not the hypotenuse, is what we call the adjacent side. Okay, so we have the opposite side, we have the adjacent side. All right. Okay, you don't have to put the entire word opposite side of theta or adjacent to theta. You can just put opposite side or adjacent side. That's sufficient. But we know it's in relation. Adjacent side is in relation to the acute angle theta, and the opposite side in relation to the acute angle theta. The only one that's in relation to the right angle is the hypotenuse. Okay, so let's go down to the part B. What type of triangle is given above? Well, it's a right angle triangle first off. Now, what is the name of the theorem that can be used to find the unmarked side of the triangle? Now, if you have a right angle triangle, guys, if you have a right angle triangle and you have the measurements, let me draw it the same way. Now, as I was saying, if you have a right angle triangle and you're given two sides, to find the third side, you use what's called the Pythagoras Theorem. That's it for 1 mark. What is the formula for finding the length of the unmarked side? Well, we use the Pythagoras Theorem, and the Pythagoras Theorem, the unmarked side we have here is the hypotenuse, right? That's the side that doesn't have a length given to us. That's the hypotenuse. So let's call this longest, let's call this, these two sides are the short sides. The hypotenuse is known as the longest side. Let's call this one A. Let's call this guy here B. So to find the hypotenuse, we usually label this hypotenuse as C. So to find the hypotenuse, which is C, we're going to say square root of the short side squared plus the other short side squared. That's the formula for finding the length of the unmarked side. Next, using the formula in D, which is right here, find the length of the unmarked side. Okay, so let's do that. So C is equal to square root of A squared plus B squared. What is A? Well, 16. So that's 16 squared plus the other side, which is 12. We're going to square that as well, which gives us what? Square root of 16 squared is 256. 12 squared is 144, which is equal to this. Now let's add the two numbers. We're going to get 400. And the square root of 400 is 20. Now, using a calculator, you can always check that out. Right? So let's try that. Let's see what we get. Square root. So the square root, 16 squared. Well, some calculators you may have to do them step by step. So let's go 16 squared. All right, just double checking. It's 256. 12 squared. You should know that is 144. But so you enter it, and then you find that you add them, right? So 256 plus the 144 that we have there is going to be 400. You can press square root of the answer, which the last answer stored in your calculator was 400, right? Square root of answer. You press this answer key here, and you're going to get 20. If you don't want to do that, you can just put square root of 400. Get 20. All right, so that's that. Now the last part, well, we have two parts. Let's go again. Write the ratio of the appropriate two sides for the following trigonometry ratios. We have sine, cosine, and tangent theta. Now, you want to remember this, okay? Sine theta is equal to opposite over the hypotenuse. So the value that goes here comes from the opposite side of theta. The value that goes here is from the hypotenuse, the side facing the right angle. What goes here is the adjacent. What goes here is the hypotenuse. What goes here is the opposite. And what goes here is the adjacent. Now you might be wondering, how do I remember all this? Well, it's simple. I use this. So, ka, toa. Right? Sine theta is opposite over hypotenuse. Opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent theta is opposite over adjacent. Alright, so we can go back to our triangle. You can scroll back up to see what we have labeled as the hypotenuse, opposite, and so forth. So let's go back up. So notice that the opposite side has 16 meters. The length of the opposite side is 16 centimeters. The length of the adjacent side is 12. And the length of the hypotenuse, which we calculated early on, is 20 centimeters. So you want to make note of that. So let's go again. So we can write that somewhere. Length of the hypotenuse is 20 centimeters. The adjacent side and the opposite sides. Opposite is the longest, which is 16 centimeters. I'm talking about opposite and adjacent. The hypotenuse is always the longest side overall. The adjacent side was 12. Let me just double check that. Yeah. Okay, so now we can just simply put those values in. The opposite is 16 over the hypotenuse is 20. The adjacent side is 12 over the hypotenuse, which is 20. Opposite side is 12 over the adjacent side. I'm going to go over it again. Opposite side is 16 over the adjacent side, which is 12. And that's it. We just put in complete the ratios, really. Write the ratios as in the ratio for each of these, 16 over 20. Fractions are typically we can always refer to fractions as ratios. Use three ratios. Using the three ratios above, show that the angle theta is the same regardless of which ratio is selected. So how we do that though? Now what you want to do, let's write it down first. Sine theta equals 16 over 20. To find theta, we need to get rid of sine. So we're going to find sine inverse of both sides. When you sine inverse this side, sine removes and leaves theta. And you sine inverse this side, but you want to make sure you write that down. Sine inverse of the 16 over 20. So in other words, you can think of it as sine transposed into the other side becomes sine inverse. We write that down. And then we enter this information in our calculator. So it's not we're going to do it. It might look a little complicated, but we're not going to do the calculation. The calculator will do that for us. Then we go to the other one. The other one is cosine theta equals, is right here, 12 over 20. And so we're going to transpose cosine over. We're left with theta on the left hand side. Cosine becomes the inverse on that side of 12 over 20. Cosine inverse of 12 over 20. For the tangent, what it is right here is 16 over 12. And so the inverse of that tangent is 16. Well, inverse of tangent of 16 over 20 is what? Let's do the calculation. All right, so we have theta equals. So the first thing we're going to do to get the sine inverse. Now, if you look at the calculator, you see calculator as sine, cosine, tangent. To get the inverse of sine is on the panel itself. So you're going to press shift, then press sine, which is going to give you sine inverse. And then you're going to enter your values. It has an open bracket, so you're going to enter 16 divided by 20. Close bracket. equal, and you're going to get the angle, 53.1 degrees. Always make sure your calculator is in degree mode, so you can press shift, then this mode button here, and say degree. You want it in degrees, not radians, not gradients. You're going to press the number 3, which will give you the degree mode. You want to make sure your calculator is in degree mode, okay? You see your answer here. If it changed the mode, the value will actually change. So let's see how that is. So if I change, let's say shift, this, and if let's say we change it to radians, let's press 4. All right, and then press equal. Let's see if that's going to be the same answer. All right, so press, right, so the sine inverse of 16 over 20 is 0.9 to whatever in radians. But we don't want it in that, so we want to make sure we get it back in degree mode. So let's put 3, get it back in degree mode, press equal, and that's it. All right, 53.13, etc. We want to run that off one decimal place, so 1 digit after the point, so that's 53.1, and we can drop the others. Because the very first digit after 3 that we're dropping, after 1 that we're dropping is 3, which is less than 5, so we're going to keep the 1 as it is. So that's be 53.1 degrees. Let's look at the next one. Theta equal, let's do cosine inverse of 12 over 20. All right, so we're going to put shift, hit cosine afterwards to get the inverse option up, then you enter 12 divided by 20 equal, get a same 53.130, etc. And let's try with the tangent now. So shift, tangent, and it will enter the same, well, not the same values, but in the same manner. 16 divided by 12, and close bracket, equal, same 53.13, etc. So all these values are the same. So we just proved that theta, no matter which trig ratio you use, the angle, the acute angle, is approximately 53.1 degrees to 1 decimal place. So if we go back to this acute angle here, the acute angle here that we have here is actually 53.1 degrees to 1 decimal place. All right, if we're asked to find this angle here, it will be what? Well, the acute angle and this acute angle here add up to 90, so it'll be 90 minus 53.1 degrees equal whatever amount that is. Okay, but you're not going to be asked that question. All right. Another way to look at it is to add 90 plus the 53. Add this 90 here plus 53 here, 53.1, and whatever the sum is, you subtract it from 180. You should get the same answer. All right. So the next question we'll be looking at matrices.